Case number 9. Look for the identity that is equivalent to the sum of tangent rho and cotangent rho. In order for us to look for that, we can express tangent rho and cotangent rho in terms of cosine, sine, or a combination of both. And let's see later if we could combine or simplify it further to come up with the equivalent identity of their sum. We can rewrite tangent rho as sine rho over cosine rho. This is the equivalent identity for tangent rho. On the other hand, cotangent rho can be rewritten as cosine rho over sine rho. Now, do not cancel sine rho here and cosine here and here as well, because they are actually added to one another. We can only use the cancellation law if we have a product of terms or coefficients. Now, what needs to be done here is an attempt to combine them into one rational expression. The LCD of these two is a combination or a product of both numerators. Just like 1/3 and 1/2, their LCD is 6. That's 3 times 2. So the LCD of these two would be the product of cosine rho and sine rho. Let me just rewrite them side by side. Automatically, it means product of them. And when we have here this denominator, we can now combine them into one by dividing this with each of the denominators, and the result will be multiplied on the corresponding numerators. So if this will be divided by cosine rho, we'll have sine rho. But to multiply that to sine rho here, so we have the square of sine rho, or sine squared of rho. Again, this is what happened. We divide this by this as our LCD. This is our LCD. This is the original denominator. So when we divide this by cosine rho, we still have sine rho, and that is to be multiplied to our numerator, sine rho. Similarly, do the same thing on the other side. Divide this by sine rho, so we have cosine rho to be multiplied with this, so we have the square of cosine rho. Let's continue here, or let's move it up a little bit here. Since our numerator is the sum of the squares of sine and cosine rho, this is actually equivalent to one of the fundamental identities in trigonometry. The square of sine rho, or even if it's not rho, theta, alpha, or any other variables, the square of sine plus the square of cosine is just equal to 1. So we have 1 over your denominator of cosine rho and sine rho. Let's try to separate both denominators. You will have 1 over cosine rho times 1 over sine rho. We have separated them into these two fractions, because if we're going to multiply them, it will just return here, because we have equivalent expressions for this. 1 over cosine rho is actually secant rho, and 1 over sine rho is cosecant rho. This means that the sum of tangent rho and cotangent rho is simply the product of secant rho and cosecant rho. This case for missing identity is now closed. If you may, to be ready for some new cases, subscribe now.